When we talked about systems of two equations with two variables, we talked about inconsistent and dependent systems. We want to revisit those ideas and see what they look like or how we identify them whenever we're dealing with systems of three equations. Our process starts the same in that we'll choose two equations. In this case, equation 1 and equation 3. This is a really nice pair to start with because our x variables already have opposite coefficients. So we can add these two equations together without updating either of them to obtain y minus 5z is equal to negative 5. Next, we'll choose equation 2 and equation 3. In order to cancel out our x variable again, we'll multiply equation 3 by positive 3. So equation 2 remains completely unchanged. And equation 3 will become negative 6x plus 9y minus 24z is equal to negative 24. Adding these two equations together will give us 4y minus 20z is equal to negative 19. Again, we find ourselves with a system of two equations. We can look at multiplying equation A by negative 4. To get negative 4y plus 20z is equal to 20. Equation B remains unchanged. And then adding these two equations together, we see that our y terms cancel out, our z terms cancel out, and on the right hand side we end up with positive 1. Or essentially we have the statement 0 is equal to 1, which is clearly not true, meaning we've ended up with a false statement. So if we have a case like this, where our variables all cancel out and what's left over is a false statement, that means we have no solution. Or another way to say that is that this is an inconsistent system, meaning there is no ordered triple x, y, z that would make all three equations true simultaneously.